Hello everybody, welcome back to the IP subnetting series. Now another thing we need to do before we climb into actually doing subnetting is making sure you're all happy with how to work with binary, because that is absolutely essential for working with subnetting and IP addressing and all that good stuff. So in this video we're going to explore the numbering systems. So first of all, we are fleshy-brained people and we deal very, very well with decimal. That numbering system that counts from 0 through to 9. Silicone brains, on the other hand, they tend to prefer binary, zeros and ones only, a 2-digit numbering system. Now the thing is, we need to get used to binary and understanding the logic that our computers are understanding to deal with binary, because if we don't, we're going to suffer to do subnetting. So, let's go see what we can do. First of all, let's look at the decimal numbering system. Let's work with what we know already and use some of that to understand binary. Dec is for 10. So there are 10 values, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm pretty sure you guys probably learned this all in primary school. And positioning affects value. I'm going to do that table that your primary school teacher probably showed you, or hell, maybe even your parents showed you before you got to school. So draw a nice little table with some columns. And working from right to left, the first column is valued at 1. The next one's valued at 10, 100, 1,000, and so forth. The way it works is you always start the columns on the rightmost with 1, and you multiply by the number of digits in the numbering system. In this case, 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1,000, 1,000 times 10 is 10,000. Rinse and repeat until you get to the value of the column that you need to work with. And as I said, position affects value. So if I stick an 8 under the 1 column, it means I've got 8 ones. If I stick an 8 under the 10s column and a 0 under the 1s column, it means I've got 8 10s and 0 1s. Stick an 8 under the 100, a 0 under the 10, and a 1 under the 1s, means I've got 8 100s, 0 10s, and 1 1. Now, the next thing is your school teachers probably didn't show you this in primary school, because I remember when I was a little kid in school, exponents were well and beyond me. I mean, I was only learning my times table when this table got shown to me, and I'm pretty sure you guys are very similar. But exponents aren't too bad to work with. But the way it works is, you've got your base value, which is the number of digits in the numbering system, and then it's to the power of 0, to the power of 1, 2, 3, 4, rinse and repeat for however many columns you want. I just want to take a minor detour just for those people that didn't take maths all the way through to their final year of school, or might have taken a different type of maths. But even not, there are people like that, and this shouldn't be a barrier to entry in IT. So a quick detour for the exponents. Exponents basically just means a number multiplied by itself a certain number of times, and it's usually written as a base value with an exponent, and it literally just means that base value, that big number, multiplied by itself exponent number of times. So for instance, 10 to the power of 0 is equal to 1. If you're wondering how do you multiply something by itself 0 times, you don't really. Shortcut, you can take anything to the power of 0 as 1. And 10 to the power of 1, well, it's multiplied by itself once, which means it technically isn't multiplied, so it's still 10. You can take it as a shortcut. Anything to the power of 1 is always itself. Then 10 to the power of 2 is 10 times 10, which, as I'm sure you know, is 100. 10 to the power of 3 is 10 times 10 times 10. But the thing is, if you already know what 10 to the 2 is, and you times that answer by 10, that gives you 10 to the 3. So it's actually not too bad to work with, because we know that's 1,000. And 10 to the 4 is 10 times 10 times 10 times 10, which, again, if you cheat a little bit, you know the answer to 10 to the 3 already. Times that answer by 10. 10 to the 4 is 10,000. Not so bad. So that makes the exponent row on that conversion table a bit easier. Now let's look at binary, the tricky one. So with binary, bi is short for 2, and there's only 2 values in the numbering system, 0 and 1. And the reason why is because a computer is a glorified light switch. It's either on or it's off. Please, no one comment that you can balance a light switch between on and off. I know you can, but you shouldn't. It's actually not a good idea. But anyway, so a computer's a glorified switch at the end of the day, light switch. It's either on or it's off, and having a multitude of switches on and off is the way we express numerical values and data and pretty much everything your computer is doing. I mean, hell, what you're watching and listening to right now is binary, just converted into a format that your brain and my brain can work with. That's beside the point. So, similar to the decimal numbering system, the positioning of the value, 0 or 1, in a table affects the value you're representing. The tough bit is, though, how do we get that table done? And part of the problem is we can't do a conversion table in binary for binary. So what we're going to do is we're going to do this conversion table, but we're going to use decimal in the top rows just to make it easier for us to look at and go, oh, okay, cool. And I'll show you how the conversion works. So first up, start the columns at 1 on the right-hand side. And then all you do is multiply by 2, just like you did with decimal. You started at 1 and kept multiplying by 10. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 is 128. 128 times 2 is 256, 512, 1024, 2048, 4096, 8192. I don't need to keep going that far, but you probably noticed a pattern there. Those numbers you tend to see quite often in things like your SSD sizes or your RAM sizes on your computer. And that's because, well, memory storage is based on binary values. But after 256, I don't need to carry on right now. Later on, when I show you Class B and Class A subnetting, yes, we will go past 128. But for now, let's just do 8 binary digits. So I'm going to make that table again. This time, I'm just not going to bring the rows down, just to keep the visuals as neat as possible. And let's quickly get those exponents in. Trust me, when we do subnetting later on, in another video, you are going to really love this little bit of exponents here. Anyway, so base value of 2. And then just plug in the exponent values going from 0, 1, 2, 3, going up in increments of 1 every time you go to the side. And hey, what do you know? Now you can tell your date that you know off the top of your head what 2 to the power of 7 is, 128. Might really impress them. Might not. Depends on who you take out for a date. Worked for me. Sort of. Let's have a look at how we can convert from binaries to decimal. So let's stick a binary number in this table. 010100001. Lovely. Now, this is what I've seen a lot of textbooks do throughout my life, where they'll say, okay, cool. You take the value of the column, which is 128, and you multiply it by the binary value underneath the column. And then you add it to the next column, which is 64, multiplied by 1, because you've got a 1 under there. And then you keep doing this over and over and over until you've got all the way down to the end. And I find this method to be a little bit time consuming and annoying, but let's just finish it and then I'll show you what I do. 128 times 0 is 0. 64 times 1 is 64. 32 times 0 is 0. 16 times 1 is 16. 8 times 0 is 0. 4 times 0 is 0. 2 times 0 is 0. And 1 times 1 is obviously 1. And then you go and add all those numbers together. 0 plus 64 plus 0 plus 16 plus 0 plus 0 plus 0 plus 1. Which gives you 81 basically. Cool. Now, I tend to do it in a different method. So, 1 means I want to use the value of the column, and 0 means I don't want to use the value of the column. It's that easy. So, what I normally do is I say, okay, cool, there's a 1 under the 128 column, which means I want to use it. So, I write 128 down. Then, I've got a 1 under the 64 column, which means I want to use it. And I'm going to go and add those two numbers together right away. By the way, this is a different binary number before somebody points out, wait, what? 128 plus 64 is 192. Now, there's a 0 under the 32 column, which means I'm not going to use it, so I'm not going to waste my time, or your time, writing 32 times 0 just to find out that equals 0. The next column where I have a 1 is the 16 column. So I'll put 16 underneath that 192 and add it to 192, which gives me 208. Lovely. I've got a 0 under the 8 column, which means I don't want to use it. A 0 under the 4 column, the 2, and the 1. I don't want to use them. So let's move on. 208. That's that value in binary. Neato. But wait, what if you want to go the other way around? What if you want to go from decimal to binary? Because, I mean, remember, your IP addresses are normally written in decimal notation because it's just easier for us to remember. What I suggest is you go with a similar method to what I use. What I do is this. I start with a decimal number, which I'll do in green, and then I try to subtract the value from the table, the value being that column's value. I'm going to work from left to right. And if I get to 0 in decimal or close to 0, I am either correct, and that's my binary value, or I am going to get very close to 0. In which case, then I set that column to 1. If the decimal goes negative, I don't use the column. Sounds a bit confusing. I've never been good at explaining this method until I actually do it with you, so check it out. Let's start with 69, funny number. 69 minus 128. Yeah, it puts me at negative 59. So that column's not going to work. So I'll put a 0 under the 128 column. Cool. Then I'm going to do 69 minus 64, which is going to give me 5. So I got close to that decimal 0 on the left there in green. So I'm going to use that 64 column. So I'm going to put a 1 under it. Then, if I look again at the next column, 5 minus 32, that's definitely going to put me into the negative 27 to be precise, so I'm going to rather put a 0 under that column and move on to the next one. 5 minus 16, that's going to give me minus 11. I have never seen a negative IP address in my life, and I've been doing networking for a really long time. So yeah, I don't think that's going to work. So I'm going to put a 0 under the 16 column. 5 minus 8, only just minus 3. Just a little bit too much though. So I'm going to put a 0 under the 8 column. And then let's see. 5 minus 4, that gives me 1, which is not negative and very close to 0. So I'm going to use the 4 column and I'll stick a binary 1 under that column. So now I've got 1 left in decimal. 1 minus 2 gives me negative 1. Damn, only just too big. So I'm going to put a 0 under the 2 column. And then let's try the last one. 1 minus 1 gives me 0, which is what I was after. Voila. I've now got the binary value for 69. Nice. Now, a little bit of advice, because this method does have a problem, which is if you've used up all your columns and you still got a decimal number on the left-hand side there, one of two things have happened. Either you made a mistake with your arithmetic, which can happen, so double check that, or you are trying to write a number larger than 255. Because with a binary table like this, where I've got 8 binary bits, the largest value I could write down is 255. If you don't believe me, I challenge you. Try it out for yourself, and you'll see what I mean. 255 is 8 binary ones. All right. Now, one last thing as well, just as a useful tip. If you ever do a certification exam, like let's say CompTIA Network Plus or Cisco CCNA or anything like that, you will not always get access to a calculator in the exam, which is why I like this method, because if I'm not feeling strong today, I could always whip out the calculator and use it. Or if I am in the exam and I don't have access to a calculator, I can always jot this down on a little piece of scrap paper that I do get access to. And if you guys are going to do an exam, same story, you get access to a piece of scrap paper as well. So this method will always work. Either way though, that was a nice little rundown on the whole how do you go between binary and decimal. It's not too bad. If you seem, ooh, this is a bit tricky, don't feel stressed out. It does take time to get good at this. I've been working at this for years, so obviously I'm pretty good at it. But otherwise, yeah. Thank you for watching, and I'll see you in the next video.